Yeah, so hello everyone. First of all, let me apologize for the inconvenience caused due to poor network issue during the time of streaming at 10 p.m. That is the reason I'm uploading this recording of the 25th day, thereby maintaining the streak of solving SDE sheet. I hope everyone will stay consistent with this. Let us begin without wasting any time. So, let me share my screen first, and I will tell you the how exactly we are going to proceed today. Hmm. Yeah, and so let us look into this. First of all, let me introduce myself. My name is Gaurav Kumar Shaw, and I am presently in my third year at IIT Kharagpur. Okay, as usual, we will be doing three problems, and I will also be giving you three homework problems. You will find the links of these three problems in the description of the YouTube channel. And what I want you all to do is try these three problems before watching the video. And in case if you are stuck, then proceed ahead. And if you're able to solve, then I would also recommend you to see it because I will be discussing a new approach maybe which will be helpful for you. So okay, so I want you all to complete this entire video. And after you complete this video, just mention in the comment to mark your attendance that you have completed this video. Okay. And I will also be giving three homework problems. So in that case, you are going to solve these three problems and upload the screenshot in the Discord channel. So in that case, the students who are consistent in these 30 days will be awarded with course coupons and vouchers with the help of which you can buy GFG course. Okay, so let us begin our study. Okay, so the first problem is implementing a function called strstr. Okay, yeah, I hope everything is visible. Just to check. Okay, so let's read the problem statement. It says that we have been given a task to implement the function strstr. Now the function takes two strings as arguments s and x and locates the occurrence of string x in the string s. This function returns an integer denoting the first occurrence of the string x in s. That is, zero-based indexing has been followed. For example, if our given string is geeks for geeks and our second string is fr, it means we have to return -1 because this particular pattern fr is not present in geeks for geeks. Okay, the f and r are individually present as a subsequence but not as a substring. So we have to make sure that it's definitely a substring and not subsequence. I hope everyone knows what is the difference between substring and subsequence. If not, I will explain it to you. But now in the next example, when we see geeks for geeks and we see the second string is for, so therefore it means that for is present in the string. So therefore we will output 5 because the first character of the string, that is f, is at index number 5, and we have to just return the starting index of the substring. So this is just basically pattern matching problem, and the expected time complexity is length of s into length of x. So therefore, this problem is trying to solve us in constant space and trying to give a naive solution only because we see that a quadratic time complexity is required, and the constraints are also pretty much small. So therefore, we can try the naive solution, and that is why this problem has been rated as a basic problem. Okay, I hope everyone understood it. So let's look into this. So basically, substring. So there are two things. First is a substring and a subsequence. So substring is always continuous, okay, and substring is not always continuous. May or may not be continuous, okay. So for example, if I write my name Gaurav and if I say our, this is a substring because our is occurring continuously. But if I say orv, so this is a subsequence because o is here, r is here, and v is here. But these are not continuous or one after the another. So we have to just return, we have to check that whether the string x is a substring of the given length of the string, that is s. Okay. So we have been given string x and x. So we have to see whether x is a valid substring of this string or not. If it is, then we have to return the starting index in which x can be found in this string. Okay, I hope everyone got it. Okay, so this is our problem. So yeah, so let us look into the concept of how exactly we are going to solve this problem. Okay, yeah, just a minute. So basically in the problem, the time complexity required was O of n square time, that is the length of s into the length of x. Okay, so this was the required time complexity. So in this case, what we are giving here, this is giving us the liberty to use two for loops. Okay, it means that I have the liberty to traverse across both of the string. So I can do something like this. Let's say this is my string s. Okay, so let's say this is my string s, and I traverse through this string. And for every character when I am here, I am checking that whether my second string is present on this or not. If it is, then I can return that particular index. Okay, so if I'm at this index, I will check from this index onward that whether this string is present here or not. If it is present, then I will return this index, and if not, I will just next do it increment by the I pointer. Okay, so this is basically traversing using two loops, and with the help of that, we will be able to get the index. Okay, so let's look into a pseudocode operation. So let's say we have two variables m and n. So m is basically the length of string s1, and n is basically the length of string s2. Now we will run loop from I equal to 0 to n. Okay, so one more thing that needs to be noted down here is that since this is our bigger string of length m, and this is our smaller string of length n. So what can we exactly do here is that, hmm, just a minute, this will be the bigger string n, and this will be the smaller string m. Okay, so if this has to be a valid substring, then we are supposed to check only up till n minus m. Okay, because after that overflow will happen, and we will get segmentation fault. So it's better to check up till this position only, less than equal to this position only. Okay, so once I'm inside this loop, what will I do? For every current index I, for every current index I will be checking whether the pattern is present or not, whether the pattern, that is the second string x, is present or not. If it is present, I will return I, and that will be our answer. Okay, so this is exactly the concept. I hope everyone got it. So let me just write a code making you understand this problem. Instead of writing on the whiteboard, I will type it out, and then I will do a dry run of the code as well. Okay, so let's start. String n1. So let's say m is equal to s dot length int n is equal to x dot length. Okay, this should be n, and this should be n. Okay, so let's start because s is our bigger string. Okay, and x is our smaller string. I hope everyone got it. Now we're gonna loop for int I is equal to 0. I is less than equal to n minus m. Okay, and n is our bigger string, m is our smaller string, and I plus plus. Okay, so I need to now do the pattern matching. So let me declare a variable called j. Okay, and I will run a new loop, and I will initialize j is equal to 0. This j variable will help us traverse the next my second string. So j will be less than n and j plus plus. Okay, so I'm now checking whether this is present or not. Now how will I check? Now I will check that whether both the strings are equal or not at the position I and the position I plus j. Okay, so let's say our second string is equal to x. Okay, so x into I plus j. Sure, this will work. And if not, in that case, what will I do? After this things get over, if let's say if it doesn't get a break, okay. So if entire this thing gets over, so what will happen here is that if now j is equal to the second string n, it means that it has traversed the entire string and it was not able to find that particular pattern. So if yeah, I'm sorry, if it is able to traverse the entire string and j is equal to m, it means that it actually was able to find that pattern. Okay, because the condition, checking condition, is it is if it is not equal to. Okay, if it is not equal to, then it will break. But if it is never not equal to, it means that if it is always equal to. In that case, it will just this loop will run completely, and j will become n. And in that case, I will just return minus one, return I. But in the suppose in some cases, if it reaches a break statement, it means that there was not a valid pattern matching, and in that case, I will return minus one. Okay, so there is one thing that I would like you all to know that here is that I'm matching the second string, that is string is equal to x plus I plus j. So x will be equal to my first string s, and this will be equal to my second string because smaller string. Okay, I hope everyone understood it. So let's compile. Hmm. As you can see, there are no compilation error, and let me submit this problem to check whether it is correct or not. Yeah, as you can see, all the test cases have passed. So this was the n square of complexity. So let me do a bit more of studying of this. So basically, to the time complexity was the length of string x into the length of string s, and since we did not take any extra space, the space complexity was O of 1. I hope everyone understood it. So let me just repeat. The loop was traversing across the string s, and the inner loop was traversing across x. And this loop was trying to find whether this particular pattern is present in x or not. If it was present, so the yeah, hello, yeah. I hope sound is coming now. Sorry, the microphone got disconnected. Yeah, so I was explaining how this n square complexity thing is working. I hope everyone got it. So now let's move on to the next problem. The next problem is a very simple problem. So this problem involves, let us not look into the code. So I hope everyone has tried it initially. So what exactly is this problem saying? We have been given a non-negative number n and two values l and r. Okay, the problem is to toggle the bits in the range l to r in the binary representation of n. That is, toggle bits from the rightmost lth bit to the rightmost rth bit. A toggle operation flips a bit from 0 to 1 and 1 to 0, and we have to print n after it got toggled. Okay, so it basically means that, let's say we have an initial string called 100101001, and we have been said this is the 0th index, this is the first index, this is the second index, this is the third, this is the fourth, this is the fifth, this is sixth, and this is seventh. So we have been said, we have been given L to R, let's say from range 2 to 5, and we have been asked to toggle the bits. So therefore this 1 will become 0, this 0 will become 1, this 1 will become 0, and this 0 will become 1, and all of the remaining bits will remain same. Okay, so this is basically the toggling of the bits from L to R in a binary representation of a number, and we have to return this number. Okay, so how exactly are we going to solve this problem? I would like you all to pause the video and think. Okay, so let's start. I hope everyone have thought about it. So there are multiple approaches. So let me discuss one approach, but I will code a different approach so that you all know both the approaches. So I can do something like this. Let's say I will traverse my given binary representation, and whatever comes before L, I won't do anything to it. And whatever comes between L to R, I will flip those bits. And whatever comes after R, I will not do anything like that. Okay. So for example, let's say if I'm not doing anything to the bits which are present before L and after R, it means that I'm just adding the 2 to the power I power to my answer. So I will keep a variable called answer, and I will add answer is equal to answer plus 2 to the power I, because if this 1 is remaining same, so 1 means that 2 to the power 0, so 1 into 2 to the power 0, so this has a weight. Okay, and this means 0, so I will not add any bits. So if it is set, then I will add that particular bit for all the values which are this side of L and this side of R. I will add a value 2 to the power I if it is set. Okay, let's say if it is not set, then I will not add anything. But in the case of L to R, if it is set, then I will not add, because if it is set, that it means that I am making it unset. So if it is unset in the new number, I should not add. Okay, and but if it is unset, then I can add. Okay, so I hope everyone got the concept. That, and let me just repeat again. So for all the bits which are in the right side of len, that is these bits. Okay, these bits will remain as it is. So if the bit is 1, it means that I will add 2 to the power I, and if it is 0, I will add nothing. But and also same goes for the all the bits to the left of R. But all the bits between L and R, I need to flip those bits. So if it is set, so it means that I will make it 0, so I will not add. So if it is set, I will not add 2 to the power I. If it is unset, I will add 2 to the power I. So this is just toggling. Okay, I'm just doing the opposite of what I did here. So this can be implemented in the form of a while loop. This can be left as an exercise. Okay, but what I will be discussing is a very shortened version of the same. Okay, by using the concept of bits operation, because that is the important thing to note here. Okay, so let's look into how exactly are we going to do? Okay, yeah. So basically, hmm. Let's say what we do here is that we traverse a loop, okay, for loop from I is equal to L to I is equal to R. We traverse in this positions only from L to R, and we check whether a bit is set or not. Okay, now how to check whether a bit is set or not? By doing this operation and I will do an AND operation with one uh, left shift minus 1. If I am doing with this operation and if this is not equal to 0, it means that this is a set bit. Okay, because let's say if I have got a 1 as a set bit position, and this means that I am shifting 1 to it's this position only. Why I am doing I minus 1? Because it is a 0 based indexing. And if L is equal to 1, it means that this will be equal to 0. Because in the question it is given that L and R, so let me just show it to you, that L and R will start from 1 to N. So L and R is following 1 based indexing, but in actual bits follow 0 based indexing. That is why we will do I minus 1. I hope everyone got it. Okay, so that is the reason we are doing one left shift I minus 1. Okay, so let me write it once. So let's say if our bit is equal to 1 0 1 0 0 1, and I'm checking this position, so I have to create a number such that I have a 1 here and all are 0. So in that case I will do an AND. So in that case, I will be doing an AND operation, and I will check that whether this AND is same or not. If it is same, so this will give 1. Okay. In that case, what I can do is basically, yeah. So kindly excuse the background. In that case, what I can do is basically check this whether this 1 is present or not. Okay. So if it is equal to 1, it means that this bit is set. Okay. So if it is set, I have to make it unset. And how to make it unset, we will look into it. So by the help of XOR operation, we can make it unset. And how to make it unset is that let's say our number is equal to res, and what we will do here is that we will do a res XOR operation of 1 to the left shift of I minus 1. So if it is set and I'm doing a XOR operation with another 1, so this is basically a 1 in this position. So this will become 0. So it has become unset. So doing a XOR with a set bit will make it 0. Okay. But let's say if it was initially unset, so I have to make it set. So how to make a unset bit set? By using the OR operation. So how will it happen? So let's say if it is already equal to 0 and I do an OR operation within 1, so this will become 1. So to make a unset bit set, we are using the OR operation, and to make a set bit unset, we are doing an XOR operation. Okay, with the same value, that is 2 to the power I or 2 to the power I minus 1. That is 1 left shift I minus 1. I hope everyone got it. Okay, so let's look into the code. So I have already implemented this. So initially, let me take a variable res and declare it with n. Now I will run a while loop from I equal to L to I equal to R and I plus plus, and then I will do a set bit. And then first I will be checking if n and 2 to the power I minus 1 is not equal to 0. If it is not equal to 0, it means that it is a set bit. Okay, because 1 and 1 will always give 1 because if it is set bit. So in that case, I will XOR this thing. Okay, and if I'm XORing this thing, it will basically reverse its bit, that is toggle its bit. And in case we have got a toggle bit, but let's say if it is unset bit, in that case I will do an OR to toggle it. Okay, I hope everyone got it. And finally, I will return res. So let me submit this problem and see. Yeah, so I can see all the success test cases have passed successfully. So therefore, this problem is correct. Okay, so let us see one more thing. So I hope the concept got clear that if it was a set bit, so if it was a set bit, we were basically unsetting it by using the XOR operator, and if it was an unset bit, we were setting it by using the OR operator, because doing XOR with 1 will make the 1 0, and doing OR with 1 will make the 0 1. I hope everyone got this crystal clear. Okay, so this was the second problem. So now let us look into the third problem. The third problem basically involves, yeah, there are multiple ways actually we can solve this problem. So I'll be discussing few of them. Okay. Hmm. So the third problem says that we have been given a string S, and the task is to remove the duplicates from it. So let us not see this code. This is an incorrect code. Okay. Hmm. Let's see. Hmm. So given a string without spaces, the task is to remove duplicates from it. So let's say if the string is zvvo, I will return zvo because v was appearing twice, but in the output it should appear only once. Okay, so only keep the first occurrence. Okay, so and in case of gfg, I will only print gf because the second g is repeating. So that is the reason I have to keep the first occurrence. Okay, so how exactly am I going to solve this problem? Okay, so in this problem, the expected time complexity is O of length of S, and the auxiliary space complexity is we have to keep it constant without taking extra space. And the constraint says that the length of S can be 10 to the power 5. So basically, we have to design an algorithm in O of 1, O of n, or O of n log n. Okay, so how exactly are we going to do this? Okay, so we have been given string S, we just have to remove the duplicates. It's very simple. So can you think of something that will help actually to do this? Hmm. Anything? Hmm. So there are multiple ways you can do it. You can use a set data structure. You can use a map data structure to store this. Yeah, if you are using set, you can use an unordered set or an unordered map. So there are multiple ways. But I will try to explain it to you a new concept in which we are not using any specifically data structure. Instead, we are just relying on our concept. Okay, because that is the most important of how we are going to solve this. Okay, so the observation based concept that will help us in understanding this problem because the data structure will make it quite easy. Okay, so let us look into this. Okay, so when you will see the editorial of this thing, you will find multiple methods. I guess 7 to 8 methods are present to solve this problem. But I will be discussing only one method in this web lecture. So that particular method is quite simple to understand as well without using any extra data structures. Okay, and we have been asked to implement in O of one space. That is why I am using that method. Okay, so let us see what exactly will happen. So let's say we declare a new string str. Okay, and what we do here is that we traverse across my given string s. So we run a for loop and we traverse across this string s. And finally, what I do here is that take a character c and I store the value of my given string s. Okay, so basically I'm traversing and I'm storing the value in a character c, and I'm checking that whether this character c is present in this string or not. In this string or not. Okay. Now let's say if it is not present, then what will I do? I will just add it to my string. Okay, because this is an unique element. Okay, so initially this str will be an empty string. Okay, and initially this str will be an empty string. So basically the first character which we will get from s of I will not be present in str obviously. So I will just add str. But let's say if this character gets repeated in this string s, it will say that yes, that character is present in str. So in that case, we will not add that character. So this is a very valuable concept. Okay, because with the help of this concept, we're just skipping over the unwanted elements. So let me just write the code and then you can understand it better. So let me declare a string. Just a minute. Yeah. So let me declare a string str. So this is string str, and I will be declaring a variable called len is equal to str dot length. Okay, and after that I will be doing for int I is equal to 0, I is less than len, and I plus plus. So I'm just traversing across the string, and once the string gets traversed, char c will be equal to s of I. Char c will be equal to s of I. Now finally, I will just try to find a string, and with the help of this, I can basically get. So with the help of a str.found function, I can just easily get. So basically, what will I do? I will do str.find function, and what I'm trying to find is the character c. So I hope everyone knows about the str.find function. If not, you can read the GFG article. So str.find function take a character c and returns the location or the index or the address of that particular character in the given string str. So, but if it is not present, so it will return a null address. So that is represented by npos. So let's say if found is not equal to if found is not present, so, or if found is equal to str string npos. So string npos basically means a null address. Okay, so if this is the if I get this value, it means that I did not get my character c in my given string str. It means that it is a unique character and it should be included in our answer. So I will just do str plus equal to c. Okay, so this is done. But let's say if it is found, so I will. But if it is able to find that given character in in the string str, so it means I just have to skip. I will do nothing. So finally, what will I do? I will just return str. Return str. I hope everyone got this. So let me just submit this code and see. if there are any errors. Yeah. So there was something is was missing. So yeah, this should not be str. This should be std. Yeah, this is basically the syntactical error, std string or endpost. Okay. Hmm. Okay. Okay. So my code is not printing anything. So I just need to write a empty string because I am doing plus equal to c. Okay. Again, it is not producing any output. Okay, okay, okay. So this has to be s dot length because s was my new string. Okay. Yeah. Yeah, as you can see, all of the test cases have passed successfully, and therefore we have solved this problem. Okay, so let me just recapitulate the concept. What we were doing here is that we were basically traversing across our given string s, and we have declared a second string empty string called str. What we were doing, we were checking that whether the given character of the present string s is present in str or not. If it is present, then we will not do anything. But if it is not present, we will just add. And how we are checking this? Using the function str.find. This function takes a character and returns the address. And if it is not present, it will just return npos. And we were just checking using the if condition f npos. So the time complexity of this problem is O of n, and the space complexity of this is O of 1. Okay, because we're not taking any extra space or array, we're just taking a declaring a string variable. Okay, so I hope this was the concept, and this was our required complexity, and it has got accepted. Okay, so this was a very short video compared to a live streaming because I did a recording. I hope everyone will listen to it properly, try to implement the questions themselves, and if possible, just try to look into the editorial as well. For example, in the toggle bits, you will see if you go to the editorial, you will see there are many methods written here. Okay, you will see a very beautiful method of only in one line you can just get it. So I want you all to understand how these methods are set. Okay, I have only discussed one, but there are multiple ways, and it's not possible to discuss all the ways in one video. Okay, so you can just look into it. After that, there is another. There is for remove duplicates problem also. In this problem also you will find almost 7 to 8 methods. You can see method 1 that uses concept of just a simple traversal concept of n square complexity. Then, as I said, using unordered set was there was also a concept. So you can just look into it how you can use a data structure of set to make it. But in this case, the space complexity will be O of n. So you can just look into many ways. So you can use a sorting condition also, but in this condition the order will get changed, so this will give wrong output. Okay, so you have to just this questions can be modified in a bit of way, and you can just get. So this was solved in n log n if you're using sorting function, or if you're using a hash map, or if you're using a set. Okay, I hope everyone got it. So I also want you all to look into the time complexity of using this algorithm, using these data structures as well, because this will be helpful from interview point of view. Okay, so I hope everyone understood it, and I'm really sorry about the network issue in the during the live streaming. Okay, Hmm. So let us. So yeah, I hope and I also want you all to solve the homework problem as well. The links of the homework problem will be there in the description, and you have to upload it in the Discord channel. And tomorrow again at 10 p.m. we will be having the day 26 of the session. Okay, so and I will upload the problem links in the description of the YouTube channel. Okay, I hope everyone understood it properly. Hmm. So yeah, bye bye. Have a nice day. Ahead. Thank you very much.